Finally. Well, first of all, let's say, wonderful to be here with so many people, so many talented engineers, to be part of this, let's say, this new movement, this Jam movement. I'm JamZig. I'm a solo developer, right? I started, let's say, the Jam journey, because I met Daniel on Berlin, let's say, the Web3 Berlin. And there actually the idea started actually to develop kind of, let's say, the Jam node in the language called Zig. Let's first tell a little bit about myself, right? I'm a blockchain engineer, right? I have some experience in Rust. I started actually on Zig 8 months ago when I started this project, because this was also one of the reasons I wanted to actually implement the Zig node. So I've been actually on different blockchains platforms before. I've been on Ethereum, Solana, Terra, and some custom blockchains implementations based on EOS and on Avalanche. And say the stuff I'm familiar with is peer-to-peer networks and performance computing. So this is a little bit of my background, right? So I come from Ethereum. I was building with a partner arbitrage systems, which was a lot of fun to do. It was kind of a game you can play without anybody involved, right? Which is really nice. To have a business without customers. So as somebody I know always says. Then I did some work on Solana. Then I did 2 years of R&D work for a company called Terra and Luna. And then I started on the JamZig protocol. Let's give a short progress update. So I started in September, let's say August and September. Since then I've been working almost full time actually on implementing Zig. And as everybody starts, right? Let's say I started in August, like trying to parse this great paper, which was already like kind of pain. I did pain to the brain, let's say, to say it lightly. But it was very challenging. So from there, actually, I started, and it was a lot of fun. Some progress in short, right? The long version is the short version. I'll take the short version. So I think I walked the same path as many people did. We have heard this many times before. So I'll skip a little bit. So the state of JamZig now is that I can import the JamDuna test vector. So that means all the public vectors are imported, and I import JamDuna, everything they have actually. So that was very nice. So the future development then will be getting ready for annual submission. And I'm working on the Jam simple network protocol at this moment in time. So I wanted to show something I was working on, because I think everybody is running into this, because especially when I was developing the PVM, I was missing kind of a way to check if my implementation was correct. Because of course you got the formal definition, but to actually really know if all the bits and bytes actually like map to what's expected. I started actually on thinking, can we make kind of let's say a fuzzer to fuzz PVM implementations, and maybe this can be of use for the community, so I can probably also open source it, or let's say give it as part of the community. So this is a little bit of the Zig layout, right, of the PVM code, right? So why that I just explained. So the core goal was so not only actually test implementation, but also actually like introduce kind of little bit flips, right? Let's say in the programs or in the instructions, so that sometimes it would like not compile, sometimes it will compile, sometimes let's say instructions will be missed, right? Sometimes you will have false memory accesses. So you can also actually test your PVM in all kinds of conditions if it handles it correctly. So that was the goal. Well, so these are like the elements of let's say the requirements I wanted. So first of all, it needs to be reproducible. Otherwise, if you find a bug, you cannot reproduce. Programmation, because you want to have kind of weird case scenarios. You want to run through them to see if your implementation does this correctly. And then let's say at the end, if you run this, then you have kind of a confidence. That's what I like about fuzzing. You get the kind of confidence that your implementation is correct. So let me give a demo. So, like a simple command line tool in Zig, right? Now I'm not running that many cases, and the C is 10 for both, like, you know, B has to do with how many bits are flipping, and so some other thing. The X means kind of a cross-compilation, so I in actually Polka VM. I didn't look at the Polka VM implementation, but I just I rewrite actually programs that be generated so that the official Polka VM can execute it. So I can fuss individual instructions, and I can fuss kind of, let's say, the programs being generated. So if you run it, and here you see some output, you see actually what it's doing right there in detail. So it's building this program. You can see, like, you know, how to initialize the registers. Here, you know, you see like bad access, right? Let's say being done. But this is actually a program being executed. And then in the end, actually, it gives kind of a small summary of, let's say, what was wrong. Right? The funny thing is, I didn't find that many things. So I did individual instruction and then a bit of all the edge cases, right? And I run it for a few months, actually, like on a VM, on Hetzner. And I didn't find actually anything, right? Let's say, in the beginning I found 2 different edge cases I missed, which had to do with kind of, let's say, wrapping around, let's say, the 32-bit space. But for the rest of the implementation was very solid. But anyway, it can be handy, and maybe we can integrate it with Fluffy Labs debugger. I can compile it to WASM, for example, with JamZig, and then we can generate like random programs, and people could first their implementation automatically. So maybe we can coordinate on that, let's say later. So let me go back. Yes. So this is a little bit of my details, right? So if you want to reach out, then it's fine. And well, thank you. Yeah, that's short. But